Hi everyone, in this video we are going to see how to find the angle between two intersecting circles, and also we are going to see the condition for orthogonal intersection. Let's suppose we have two circles like this. They are intersecting circles and they intersect each other at points A and B. The equations of the circles have been provided, and from there we can easily determine the coordinates of their centers and also their radii. So when two circles intersect each other, what would be the angle between them? Well, it's actually the angle between the tangents onto the circles at a point of intersection. So let's pick the point A and let's draw two tangents, one tangent on each of the circles. And let's suppose the tangents look like this at the point of intersection A. I have maintained the same color so that we can easily understand which tangent belongs to which circle. And now this angle theta, which is the angle between the two tangents at that point, this angle theta is actually called the angle between two intersecting circles. That means for these two intersecting circles, the angle between them would be the angle between the tangents at the point of intersection. So if the equations of the circles are provided, somehow we have to be able to find out what would be this angle. So let's see how we can do that. We have to do a little bit of construction here. First, I am going to join C sub 1, the center of the larger circle, with the point A. Similarly, I am going to join C sub 2 with point A, and then I am going to join C sub 1 with C sub 2. From the given equations of the circles, we can easily find out the coordinates of their centers. And using the coordinates of their centers through the distance formula, we can find out the distance between C sub 1 and C sub 2, and that is going to look something like this. I am simply using the distance formula to find the distance between C sub 1 and C sub 2. And if we simplify this a little bit, it's going to look like this. And then if we take a square on both sides, the square of the distance between C sub 1 and C sub 2 would be like this. And then if we expand the right hand side, if we remove the parenthesis, then it's going to look like this. And we're going to need it very soon, so let's keep it handy. Next, if we look at the angle C sub 1A, C sub 2, let's call it angle alpha. Then let's try to find out what would be the value of alpha in terms of theta. Now let's look at each of the circles. C sub 1A, that radius will be perpendicular to its tangent, and similarly C sub 2A, that radius will be perpendicular to its own tangent. So from here, can we write it like this? This is like the complete angle around the point A. And from here, if we find out the value of alpha, we can clearly see that alpha will be equal to 180 degree minus theta. And next, we are going to use cosine law on this little triangle, which is C sub 1A, C sub 2. If we try to find the cosine of the angle alpha, which is the angle C sub 1A, C sub 2, that angle is the alpha angle. And if we try to find the cosine of that angle, then using the cosine law, we can write it like this. Next, we are going to use the value of alpha, which is 180 degree minus theta. So we can write it like this. And cosine of 180 degree minus theta is actually negative cosine of theta. So we can write the equation like this. On the left hand side, it becomes negative cosine of theta, and on the right hand side, it's exactly like that. And now let's multiply both sides by a negative 1. So our equation going to look like this. Left hand side becomes positive cosine of theta, and on the right hand side, the terms in the numerator change their signs. So if this is the value of cosine of theta, then what would be the value of theta? Well, it will be cosine inverse of that expression. So that is the angle between these two intersecting circles. The angle theta, that is equal to cosine inverse of C sub 1 C sub 2 whole squared minus R sub 1 squared minus R sub 2 squared over 2 times R sub 1 times R sub 2. So if we are provided with the equations of two intersecting circles, then we can easily determine their radii from the given equations. Also, we can easily calculate the square of the distance between the two centers, and then we can easily find out the value of the angle theta. Next, we are going to talk about orthogonal intersection. When two circles intersect each other orthogonally, that means the angle theta is equal to 90 degree. So if the angle between the tangents of two intersecting circles at a point is equal to 90 degree, then we say that the circles intersect each other orthogonally. So for orthogonal intersection, the condition is that theta has to be 90 degree. Now when theta is equal to 90 degree, what would be the value of cosine of theta? Well, that will be cosine of 90 degree, and obviously that is equal to 0. So the value of cosine of theta that we just derived right here, we can see on the screen, which is towards the top right hand side, that expression's value becomes 0 for orthogonal intersection. That means when theta is equal to 90 degree, the value of that expression, which is equal to cosine of theta, in this case it will be cosine of 90 degree, and that is equal to 0. Now let's multiply both sides of this equation by 2 times r sub 1 times r sub 2. then our equation going to look like this. And here let's plug in the value of this c sub 1 c sub 2 whole squared, the square of the distance between the two centers. So this is the value of c sub 1 c sub 2 whole squared, and then of course we have minus r sub 1 squared minus r sub 2 squared. So what would be r sub 1 squared? Well, that can be written like this. This is g sub 1 squared plus f sub 1 squared minus c sub 1, that's the lowercase c. And what would be r sub 2 squared? Well, that can be written like this, and this entire expression is equal to 0. In the next step, I am going to remove the parenthesis. Then our equation is going to look like this. And here we can easily see some of the terms will cancel out each other because of the positive and negative signs. So this is the first pair that cancel out each other. There is another pair that cancel out each other, and then another pair, and this is the other pair that cancel out each other. So now we are going to be left with something like this. And if we multiply both sides by a negative 1 and reorganize the terms, finally this is going to look like 2 times g sub 1 times g sub 2 plus 2 times f sub 1 times f sub 2 is equal to c sub 1 plus c sub 2. These are lowercase c, these are the constant terms in the equations of the circles. So this is the necessary condition for orthogonal intersection of two circles. So if we are given the equations of the circles, and if we are asked to find out if the circles intersect each other orthogonally, then we can try to calculate the value of the left hand side and the right hand side separately. And if we notice that the values are equal, then we know that the circles intersect each other orthogonally. So this is called the condition of orthogonality or condition of orthogonal intersection. I hope the derivations made sense. Thank you for watching. See you in the next video.